Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rusyaidi bin ROHAIZAN and my metric number is 201816. And my teammates are Muhammad NAJWAN bin ISHAK 201775, IRFAN bin FAIZA 200971, and Muhammad IRSHAD bin Muhammad Ali 201698. And this is our project presentation for AED 0613. Our case of study 1 is about to design a privacy roof for ATM in administration building in CFS RIUM. First of all, in CFS RIUM, students need money for many purposes such as pay fee, buy study necessary and tools. However, students were set to a limit money for safety purpose. So CFS management provide an ATM machine as a solution for them to keep their money. The ATM machine was provided since CFS settled its renovation for the first batch use. Okay, the objectives of this project is to improve the level of security of ATM machines for student use. Second is to calculate the ideal measurements to design the roof over the ATM machines by applying mathematical concepts such as trigonometry. And last is to make sure people can't view the keybar of ATM machines in order to keep student privacy in aspects of password and any relevant information. Our problem statement, as you guys can see here, this is a view from the second level administration building, and okay, the problem is the ATM is located at the public and open area of the administration building, and because of that, students from high levels of the building can see the pin bar of the machines. Okay, the procedure of our project is first we collect the data of measurement by using smart measure on our smartphones and also apply ratio application by comparing the real size of materials and people at surrounding to some measurements that we have collected. We repeated this measurement 2 times on different days to get the best and most accurate result. Okay, some of the data that has been recorded are the distance from the ATM machines to the walkway of admin building. Second, the height of level of the second floor walkway from the ATM key pin, and last, the height of ATM pin bar and proposed roof area from the ground level. Okay, diagram 1 illustrates the front view of the ATM machine from the counseling and Masjid management block. From that view, we measure the distance from the ATM key point horizontally to the bridge walkway of the building and the height of eye level from people from second floor of building to get the inclination angle of the viewpoint to the key pin of ATM by applying the tangent concept in trigonometry subject in mathematics. Meanwhile, diagram 1b illustrated the side view of the ATM. From that view, we measure the distance from the ATM key pinpoint horizontally to the walkway that is located beside the elevator of the building and get the inclination angle from the viewpoint here to the key pin of the ATM. Then, we measure the height of the proposed roof from the key pin level by using tangent concept again, and the angle of the inclination that we already got from diagram 1a, we took the measurement of the overhang roof that we plan to design from the front side of the ATM. Next, we use the same concept and application to measure the length of the overhang roof from the side view of the ATM using the angle of inclination from diagram 1b. Lastly, as a result, we got the minimum length and width of the proposed idea of roof that we plan to design, that is 5.87 meters square. To get more accurate data, we repeated the procedure 3 times so that we hope that our ideas and findings could help and keep students' privacy from being invaded. Carry on, our second case of study, which is modification of roof design for the selected walkway in CFS RIUM. In CFS, there are many blocks of building and walkways, so that we assume that the majority of community in CFS walk as their main method to move a site to another. However, the walkways are exposed from the microclimate aspects, such as sunlight and rainfall. To protect pedestrian users from those aspects, CFS management provided a roof walkway as the solution of this problem. The objective of our second project is to calculate the suitable size of roof in order to give students max level of comfortability. Second is to compare the current roof size with the standard measurements of roof that must be designed. Third and last, to identify the best combination of measurement that best at preventing the sunlight exposed to the walkway area. Our problem statement is the roof was designed quite narrow as there are some areas of pathway exposed to the sunlight. To systematize our study, we focus specially on the sunlight problem that happens usually at 2 p.m. and 4 p.m. as the walkway is usually busy with users on that time. Our procedure of this project is we gain the measurement by applying smart measure on our smartphones and also use ruler and ratio application. In addition, we repeated this process 2 times on different days to get the best and most accurate calculation. Some of the data that have been recorded are height of the roof from the ground, width of the walkway and roof, and the length of area sunlight exposed on the walkway area. Okay, diagram 2A illustrates the section AA of the walkway that is located facing the student center from the stadium. From that view, we measure the height of the roof from ground and the width of the walkway and current roof. It also shows the area of the walkway that was exposed to the sunlight at 10 a.m. and 2 p.m. From the measurements, we can calculate the angle of inclination of the sunlight on those times that we set. Meanwhile, from all the related measurements, we can calculate the inclination angle of the sunlight on 10 a.m. That is 80.54 degrees. From that measurement, we measure the length of the overhang that we propose on 2.7 meter. Meanwhile, at 2 p.m., the overhang length from the current roof side was calculated by applying tangent concepts such as diagram 2C. Next, we use the same concept and application to measure the length of the overhang roof from the side view of the roof. Lastly, as a result, we got the minimum width of the proposed area of roof that we plan to design, which is 4.49 meter. To get more accurate data, we repeated the procedure 3 times so that we hope that our ideas and findings could help and be the most relevant solution to our study. As a conclusion, we can conclude that mathematics is very important in our daily life. As we can see from this project, both cases are solved by using mathematical methods, which in this case involve trigonometry. We managed to find the design of the roof that can maximize the safeness of the students' account pin while using the ATM. While for the second case, we managed to find the best possible length to be added to the roof in order to totally provide shades for the students from the sunlight, especially at the peak time, which is 10 a.m. and 2 p.m. So we hope that our research and improvements ideas would be responded to all communities' benefits. And this is our reference of the project, and that's all from me. Assalamualaikum warahmatullahi wabarakatuh.